Hello everybody. I, Srimati Shutopadev, pursuing my PhD work from Department of Chemistry, Tripura University under the supervision of Professor Arkanath, now presenting my work entitled Incorporation of Bile-Salt and Laser Dye using layer by layer self-assembled technique. Biosurfactants with laser dyes are now gaining immense interest due to their potential biological application. From biotechnological and biomedical point of view, they have shown promise for solubilization of drug and development of advanced devices based on their eco-friendly, no-toxic, biodegradable nature. They are widely used for designing antimicrobial coating and biosensors. In order to construct and organized biomaterials in two or three-dimensional space from the nanobiotechnological perspective, layer by layer is one of the most promising way for fabricating multi-layer film with precisely controlled thickness and architecture on a nanometer scale. Now discuss the aims and objective of this work. Keeping this fact in mind, the present work has been undertaken with the following objectives: to fabricate an ultra-thin film of Nile blue doped in a bile salt, to examine the factors affecting deposited layers, concentration, temperature, and pH, to this molecular assembly process using UV visual and steady-state fluorescence spectroscopy, to investigate the morphological variation of the composite by scanning electron microscopy. So the chemicals required for this work includes Nile blue A, which is a cationic bench of inoxazine laser dye used to stain glycolipids and has been extensively used as biomarkers and biosensors. Sodium dioxycholate, which is an amphiphilic bile salt, steroidal skeleton derived from the cholesterol in the liver, and polyaluminum hydrochloride. Now we want to know how we construct the ultra-thin film. The film was constructed by LBL self-assembled technique. The layer by layer is an effective and experimentally convenient method for the fabrication of ultra-thin films of water-soluble molecules by alternate deposition onto solid substrate. Now discuss the results. The absorption spectrum of NB shows the intense light absorption band with a maximum centered at 635 nm for monomer and a shoulder around 594 nm. The supramolecular aggregation of the dye molecules occurs, and this absorption band in the visible region is due to pi to ester transition. The bile salt in its pre-micellar concentration range induced dimerization and the J dimers are formed. The absorption spectrum 635 nm in solution changes to a sharp band at 592 nm and with a weak shoulder at 630 nm in mixed solution of NADC NB. In the absorption spectrum of one trilayer pH NADC NB film, the monomeric peak 635 nm has been reached to a weak hump, whereas the dimeric band becomes strong with an intense peak at 586 nm. The interaction between NADC and NB was strongly influenced by direct electrostatic forces between the CW group and the N plus in NB is also a pi-pi staking and bond interaction makes some contribution. Now in fluorescence spectroscopy, in NADC NB film aggregation of dye and the intramolecular vibrational coupling may correspond intersystem crossing, which facilitate the reduction of 0 bond in comparison to aqueous NB, and the mixed solution shows the intense 0 bond. Now we discuss the layer dependency. The band profile in the absorption spectrum of this complex trilayer film is different in comparison to that of pure NB in solution. The blue shift in the monomer peak of NB indicates that there is an aggregation of NB molecules and the aggregates are of H type. The dimer of NB is absorbed mostly in comparison to the monomer on the NADC layer, electronic and addition forces acting mostly to the dimeric NB molecule on substrate. Now we observe that the multilayer growth in this complex film was almost linear up to 10 trilayers. After 10 layers, the change in absorption intensity at 586 nm was not linear, rather zigzag pattern. The roughness of the film might have increased in such layers. The NB molecule influences mostly to the dimeric NB molecules on the substrate. The intensity of the dimeric molecule is higher than the monomers of NB. Now we discuss how the concentration of dye affects the film. The intensity of absorption increases with the increase of concentration of NB in its solution. It is widely recognized that NB undergoes self-regulation in water on increasing its concentration. A slight blue shift of the maximum absorption of the dimeric band around 15 nm is due to H-type aggregation H-type aggregation of NB dimeric molecules on the substrate. The monomeric band do not show any shift in the whole range of concentration. The dimer to monomer ratio is also increased with the increase in concentration of NB in solution. The absorbance of the monomer of the Nile group is increased gradually with the absorbance of dimer dye as the concentration of dye is increased gradually. The dimer is monomer or ratio decreases with the increase of dye concentration, and the absorption maxima increases with the increase of dye concentration. The effect of temperature on a tri-layer film was found to be remarkable. Here we observed that the intensity of absorption increases remarkably with bathochromy shift from 586 nm to 602 nm. One possible reason for the above observation is that the bile-salt mycelids are very sensitive to temperature. As the temperature increases, the kinetic energy of the molecule increases and the aggregation happens. With increase in temperature at high concentration of bile-salt, the concentration of anion increases and aggregates with higher rate with dye molecules. Here we discuss the effect of varying pH on film. We observe that the absorption gradually decreases as pH decreases because NADC molecule gets neutralized by hydrogen ion, so deposition of dye molecules decreases. Dimerization increases and the absorption band shifted towards the left with increasing pH. The monomeric band becomes less important in comparison to a very wide, intense blue shifted dimeric band. Now the morphological characterization of the film has been studied. The surface morphology of pH NADC NBS self-assembled tri-layer film has been studied by scanning electron microscopy or SEM. The morphological analysis of the thin film, including H aggregate, was predominant in lamellar-like structure or thin plate-like structure, while the monomeric dye thin film shows the granular cluster-like morphology. So I conclude that the self-assembled films of NBA with NADC can be fabricated by LBR technique. UV visible absorption spectroscopy, steady-state fluorescence spectroscopy, and SEM studies confirm the incorporation of them and microcrystalline aggregate formation, which largely depends on concentration of dye, temperature, pH. I would like to express my deep sense of gratitude to my supervisor, Professor Arkenath, for his valuable advice and guidance, and also gratefully acknowledge the CIC Tripura University for providing the excellent equipment facilities to perform this work. Thank you.